Although we've already talked about using the graphing calculator to help us out with graphing, in section 1.9 here, we're going to really just focus on the graphing calculator. One of the things you'll notice is that the calculator that I'm displaying is the TI-83 Plus. Do not worry if you are working on the TI-84 Plus. I hope you are. But I'm just using an older version of the calculator. Most of the same functions that you have on your calculator are located on the TI-84 Plus and are located in the exact same place. One of the things that we didn't spend a lot of time with in Algebra 2 was changing the window setting. The window setting was at the top of your calculator. It was right here. And when you press it, this screen is called the default window settings. The TI-84 Plus, you might actually have some other stuff listed. What we're working on right now, we're worried about these: X-min, X-max, Y-min, Y-max. What that does is it says that the coordinate plane that pops up on your graph, it goes 10 units to the right, it goes -10 to the left, it goes 10 units up, and -10 down. And another thing that I want to remind you about with your calculator is that the screen of your calculator is a rectangle, not a square. So think about that when you graph things. So the first thing we're going to talk about is choosing an appropriate viewing rectangle on your calculator screen. The problem we're about to do, you really don't need to change the window on it, but for the purpose of talking about how to change the window, we're going to use this problem: y equals x squared plus 3. Remember that you're going to put this under y1 equals, under the y equals button. And when you graph it, you should see this screen. It's a parabola. Its vertex is on the y-axis at 3. It opens up. So now let's go and change our viewing window. Go to the window button and change the viewing window so it says x-min is -4, max is 4, and y-minimum is -4, and the maximum is 4. One of the things I want you to remember is that x and y minimum mean how far do you want to go in the negative direction, or to the right or down. And x max always says how far do you want to go to the right in the positive direction. Y max always means how far do you want to go up in the positive direction. And then this screen pops up. Well, clearly making the viewing window smaller did not help us see the graph better. So now I only see this little part up here. A lot of times we want to see the graph, let's see, we want to see it look more like this. So what can we do to do that? Well, instead of making the viewing window smaller, let's make it larger. So for no apparent reason, I'm going to go back to my window settings, and I'm going to change it to go from -50 to +50, just to see what that does with my screen. And this is the screen that pops up. Alright, so now my axes, they look like these big, thick lines in the middle of the graph, but at least I can see the graph bigger. So maybe -50 to +50 wasn't the best viewing window. So is there really a best viewing window? Well, when we get to the next problem, you'll see more why we need to be able to change the viewing window. A lot of times, one of the reasons we would change our viewing window is if we want to find where two graphs intersect. So you're going to graph on your calculator y1 equals 3x squared minus 6x plus 1, and in y2 equals, you're going to graph 0.23x minus 2.25. And we want to see where this parabola and line intersect. So this is the screen that you should see. So if I look at this, it looks like it intersects somewhere in here. But I'm not quite sure. I mean, it looks like the vertex of the graph may be hitting that line. So in order to really see what's going on, I'm going to have to zoom in on that location. And I'm going to tell you, using the zoom in function, for those of you who have used that before, I'm not particularly fond of it because when it zooms in wherever the heck it wants to. Sometimes I want to zoom in on a very particular location. So here's the deal. I know by looking at the tick marks that I want to look somewhere between 0, 1, 2, maybe 0 and 3 on the x-axis. And then on the y-axis, maybe I want to see between 0 and 3, maybe 4. Is there one right answer to how you should scale this? No, but I want to see in that general area. So I'm going to change my calculator window. This is going to be x min, x max, y min, and y max. And I should clarify, because I just messed this up. I don't want to go from 0 to 4. I want to go from 0 to negative 4. And I hope you were looking at this going, why is she saying 4 when she's pointing at negative 4? So if I'm going from 0 to negative 4, this is my maximum because it's bigger, and this is my minimum. All right, so this is where I'm at. So I zoomed in, and it still looks like they intersect. I'm not sure if they do. If you don't remember this from Algebra 2, one of the things you can do to find if a graph intersects or not is to press the trace button. And when you press the trace button, number 5 says intersect. I'm sorry, not trace, second trace, because we want to go to the calc function. So if you press second trace, number 5 says intersect. And then you'll get this screen that pops up. Just hit enter 3 times, and it's going to give you an error message. So if there's an error message, one of two things happened. Either it doesn't intersect, or we did something wrong. So why don't we try zooming in a little bit more? Now that I'm looking at this, this is negative 1, negative 2, negative 3, negative 4. How about I go down to negative 3? And then let's see, this was 1, 2, 3. How about I go from 0 to 2 on the x-axis? So now I'm going to change my x window to go from 0 to 2. And my y window is going to be between 0 and negative 3. And I'll write it this way. And now this is what I see. And it still looks like they're intersecting, possibly. Intersecting, touching, same thing. Intersect does not necessarily mean that it's going to pass through. Well, I'm going to tell you the window setting that my book uses. My book used x from negative 2.25 to 1.25. And then the y values, it went from, the minimum was negative 2.25 and the maximum was negative 1.85. I'm sorry, I misspoke. This was 0.75. So the x values went from 0.75 as a minimum to 1.25 as a maximum. And the y values, negative 2.25 as a minimum, negative 1.85 as a maximum. And now look at this graph. If we zoomed in far enough, it became abundantly clear that those two graphs don't actually cross each other. Again, we don't always use changing the window in order to find a point of intersection. Sometimes we just have a graph, one single graph, that we put on our calculator and it doesn't show up in the viewing window. So sometimes we have to change the viewing window. In the last section, we talked about circles. What I didn't mention was how to graph a circle on your calculator. What I did mention was that it took some major algebraic manipulation in order to do it. Well, here's how it works. In order to use the graphing calculator to graph anything, until later in the year when we talk about how to change the graphing calculator to different modes, you need to solve this equation for y. So you would subtract x squared, and then you have to square root it. But you need to remember, when you square root something, you need to do this. So there are really two equations that you're going to put in your calculator. the first equation is going to be positive square root of 1 minus x squared. And the second equation is going to be negative square root of 1 minus x squared. So if you have the TI-84 calculator, when you type it in, it's going to look like what I wrote here. If you have a TI-83 that you inherited from someone, it's going to look like this. You're going to need to use parentheses. It's not that big of a deal. Either way, you'll get the same graph. Now, this is the circle, which really doesn't look like a circle. It looks like an ellipse, but remember the screen is rectangular. That's why it looks like an ellipse. But that's my circle on the calculator. And some of you may be going, how did you get that circle? When I plugged it into my calculator, mine looked different. One of the things that I did was I pressed the zoom button, and then I went to number 6. That's called zoom standard. What it does is it resets the default window setting. The default window setting was x minimum negative 10, x maximum 10, y minimum negative 10, y maximum 10. So we're looking at this circle and we're going, it's awfully small. What should I do to make it look bigger? Well, if you kind of notice, if you look at the screen, it looks like it probably goes through 1 and negative 1 on the x-axis and 1 and negative 1 on the y-axis. So maybe we'll make our x values go from negative 2 to positive 2, and our y values go from negative 2 to positive 2. When I make that change, now that circle is much bigger on the screen. It looks a lot nicer. You just have to remember that your tick marks are 1 and 2 over here, negative 1, negative 2 here, 1 and 2 here, negative 1, negative 2 here. Let's look at this relatively simple algebra equation. If I said solve this equation, you're going to look at it and you're going to go, oh, I'm going to add 5 divided by 3 and I'm done. Sometimes there are equations that were given that are a lot more extravagant than this. And as long as your equation is equal to 0, one of the things you can do to solve is to set y equal to your expression that's equal to 0 and graph it. The solution will be the x-intercept. It'll be where the graph hits the x-axis. Now my graphs are starting to look a little fuzzier, I'm sorry. So if you graph this in your calculator, your graph probably looks like it hits the x-axis at 2. But you know that's not right. So maybe we'll change our window to kind of see that region better. Maybe I'll change it so x goes from, maybe we'll go from 0 to 3. And we'll make our y go from, maybe we'll add, I want to see something above the x-axis, so maybe I'll go from 2 to negative 3, and we'll see what happens. So that actually made it look better. So remember, my x-axis goes 1, 2, 3. So now clearly you can see that the solution, the x-intercept, is between 1 and 2. Well, we already know that 5/3 is between 1 and 2, because if you put it in your calculator, 5 divided by 3 is 1.6 repeating. There's a function on your calculator that will find that answer for you. It's under second trace, number 2, 0. So go to second trace and then number 2. And then at the bottom of your screen it says left bound. Well, you know that the answer is between 1 and 2. So even though you see a little cursor blinking, type in the number 1 and hit enter. And what that does is it locks in 1 as a number to the left of the 0. Now it says right bound. So we're going to make 2 our right bound. So just type in 2 and enter. Then when the calculator says guess, just hit enter again. And at the bottom of your screen pops up 1.666 and a bunch of sixes and probably a 7 at the end. That's because it can't write all the digits. It's 1.6 repeating. And 1.6 repeating is 5/3. If you're not sure what a repeating decimal is as a fraction, there's a cool little trick on the calculator. If you go to the face of the screen, and I'll show you a picture in a second. If you type this into the home screen, and then you hit Math, Enter, Enter. Math is a button on the left-hand side, and then just hit Enter 2 times. What will pop up on the screen will be 5/3. So, let's talk about graphing a quadratic equation algebraically and graphically. Not all solutions to equations are integers, or rational numbers for that matter. Sometimes the answers are imaginary. We talked about imaginary numbers in Algebra 2. Sometimes the numbers are irrational. Irrational numbers were non-repeating, non-terminating decimals. When you graph a quadratic equation, one of 3 things is going to happen. Either the graph is going to cross the x-axis twice, in which case it has 2 solutions. Sometimes only the vertex touches, in which case it has 1 solution. But it is highly possible that you can graph a quadratic equation and the parabola never touches the x-axis at all, in which case it has no solution. Or it really has imaginary roots, but it depends on whether we're working in imaginary numbers or if we're working in just real numbers. So, algebraically, we would solve this using the quadratic formula because it's not factorable. So x is equal to the opposite of b is -4. Remember, a, b, c, plus or minus the square root of b squared minus 4ac all over 2a. So you would get 4 plus or minus the square root of 16 minus 8 is 8 over 2. The square root of 8 reduces to 2 square root of 2. And then this reduces again to 2 plus or minus the square root of 2. So there are 2 irrational numbers. One of them is 2 plus the square root of 2. The other one is 2 minus the square root of 2. If instead I want to graph this and find the solutions, when I graph this in my calculator, I actually went and I changed the window settings. I didn't change y, but I changed x to be between -1 and 5 so that I got a better idea of where my zeros were. One of them is between 0 and 1. Let's see, 2, 3, and then this one's between 3 and 4. If I know what integers or tick marks on my x-axis that a 0 is between, then I can use the 0 function to find the answers. Now I have to do this twice if there's more than one answer. So I would go to second trace, number 2, 0. To find this 0, I would put in my left bound as 0, enter, and then I would press 1, enter, and then when it says guess, I would hit enter again, and it's going to give me a nasty decimal that says something like 0.58578644. So we'll just say it's approximately 0.59, which I bet is 2 minus the square root of 2. To find the other answer, I'm going to go to second trace again, number 2. But this time, my left bound is going to be 3, and my right bound is going to be 4. And remember, when you see guess, hit enter again, and it's going to tell me the answer is 3.4142136. I'm going to round that to 3.41. What's the right answer to round to? Yeah, sometimes we tell you, but in general I round to the nearest hundredth place. The problem with the calculator is the calculator will not give you the exact answer like algebra will. So it kind of depends on what information you need. There are going to be times when you need the exact answer, and there are going to be times when you just need the decimal approximations. Although this next problem is actually factorable, if you look at it and you're like, oh, I know this factors into x minus 2 squared, that's cool. But if you're looking at it and you're like, I can't remember how to factor it, you can always use the quadratic formula. Either way you do it, you're going to find out in the end that x is just 2. Whether you use this method or the quadratic formula, what's going to happen with the quadratic formula is you're going to get a 0 under your square root sign. Well, the square root of 0 is 0. You're going to end up with 4 over 2, which is 2. Well, if there's only one solution, that means when I graph this, the graph will only hit the x-axis one time. Here's what the graph looks like on my calculator. I didn't even change the window settings. I left it the same. You can see that it kind of comes down here, hits here, and then goes back up. When the graph only hits the x-axis one time, that means it bounces off rather than passes through, you will be unable to use the 0 function. The only time you can use the 0 function to find the zeros of a polynomial is if the polynomial passes through the x-axis. Now let's talk about a problem that's not factorable. So in order to solve x squared minus 4x plus 6 equals 0, I'm going to use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to get 4 plus or minus 16 minus 24. That's negative 8. And you can't take the square root of negative 8. That means that this answer is imaginary. So there is no real solution. And here's what the graph looks like. It never hits the x-axis. So if it never hits, there are no solutions. This last problem I'm going to talk about in this video, it's another simple one that can be done algebraically with no problem. So all you have to do is, I would add 3x because I like to make my x positive. And then I would add 20. So I would get 25 is equal to 11 over x, and then I would divide by 11, and I would say the answer is 25 over 11. If you really want to turn it into a mixed number, it's going to be 2 3/11. If you want to turn it into a decimal, it's going to be 2.27 repeating. But there is a graphical way of doing this problem. What I like to show the Algebra 2 kids, particularly as we get close to the ACT, sometimes you're given an algebra equation that maybe isn't as simple as this. Well, there's this neat little trick for finding the solution. If you think of these separately as equations, as this being y1 equals and this being y2 equals, the solution is where the two graphs intersect. And we have that intersect function on the calculator. So we're going to put 5 minus 3x in y1 equals and 8x minus 20 in y2 equals. So when you graph them, you see this. Now, the textbook that I have, it actually does zoom in on it. We don't even need to zoom in on it. In order to find where these two graphs intersect, you're going to hit second trace, which is the calc function, which is over here. Number 5, intersect. And then I want you to hit enter 3 times. And it's going to tell you that x is 2.2727273 at the end, but that's because it's really just this. So again, if you are given an algebra equation, particularly one that has like decimals and fractions in it, and you're like, I don't want to do this algebraically, there's this neat little trick where all you have to do is put one side of the equation in y1 equals, the other side in y2 equals, and find the point of intersection. And that's going to give you the solution, which is a really great technique on a multiple choice test.